Good morning, everyone, and thank you, Mary, and thank you also to the wonderful team at White October for putting on this event in my hometown. I am very excited to be here to talk to you about this today. The first thing I want to say is that while I am up here on stage, this is actually a talk that was originally a joint effort between myself and my now ex-colleague, Jessica DeVita. Ex because she no longer works at Microsoft, not because, anyway. I hope you can share the love for Jessica, who is a wonderful colleague, and many of the most interesting insights in this talk come from her and a community that she is part of that I'll be telling you more about later. Today, I'm going to talk to you a little bit about incidents, outages. I suspect that many of you in this room work on production services. And I'm excited to talk to you about incidents with this audience in particular because almost all of you in this room are leaders or are on a path to becoming leaders in your community. And outside of this room, I feel happy that this is a comfortable, happy community who are interested in learning about how to do things better in our industry. But outside of this room, I think some of what I'm going to be talking about is bordering on sacrilegious in parts of our industry. We have a lot of old and broken ideas about how work works, particularly operational work, where we deal with incidents on a daily basis. It's going to take some brave leaders willing to demonstrate better ways of doing things to bring about change in how we learn from incidents and to recognize fully the role that humans play in our systems. But I'm getting ahead of myself because we're going to start with a short story, a story about this aircraft, the B17 Flying Fortress. And I'm not going to tell you the whole story to start with. I'm going to tell it in two parts. And we'll return to the second part of the talk and examine it a little bit later on. During World War II, this aircraft, the B-17, was involved in a series of accidents. We don't know all of the details of these accidents. It was wartime, and some of this remains secret. But what we do know is that there was a significant series of accidents, probably more than 100 and possibly several hundred. And in each case, something fairly similar would happen. A B-17 would land on the runway successfully. And after landing, it would start to taxi back to its parking stand. And somewhere, either on the runway or the taxiway, on the way back to park, this would happen. The landing gear would seem to just go out from underneath the aircraft. And the pilot and the crew would be sat belly down on the runway. As you can see, it's probably not a particularly good thing to happen to the aircraft from a financial point of view. But in each case, investigators would go and look for evidence of mechanical or electrical failure. Did the landing gear break? What happened? And in each case, they would conclude that there was no mechanical or electrical failure. I suspect some of you know where this is going. They concluded that the cause of each of these hundreds of accidents was pilot error. Does this story raise questions for you? I hope so. We'll come back to it, but for now, just ponder the fact that the investigators on some level were correct. No mechanical or electrical failures had occurred that led this accident to happen. But the accidents kept happening. We'll come back to this later. So now let's just look at the structure of the rest of what I'm going to talk about today. First, we're going to consider a question. Why should we want to learn more from incidents? Why do we even do this? The answer may seem obvious to some of you, but I think I have a twist that you'll find interesting. We'll then talk about 4 common traps, things that we all do when we investigate incidents. And these traps are traps identified by a community of researchers who've studied systems similar to ours in other industries. And we'll hear more about them later. And then in addition to talking about the traps, we'll talk about 4 helpful practices, steps you can take in your teams starting tomorrow, which will help you learn more from incidents. So let's get started. Why should we want to learn more from incidents? Anybody want to shout out why they think we should learn more from incidents? I promise there are no wrong answers. So they don't happen again. And this is a perfectly valid answer. We want to prevent incidents. But I have a question for you. Think about the systems that we work on. Can we prevent all incidents? Is there a time in the future that you can imagine when there will be no incidents? Here's the thing. Most of the systems that we work on, I work at Microsoft, so this is particularly true for the large-scale systems that I work on, but I think it's true even at much smaller companies. Most of the systems that we work on are complex systems. They are systems composed of many parts, and often the behavior of the system comes from the interactions between those parts as much as from the parts themselves. Complex systems behave in interesting and counterintuitive ways, and I'm sorry to say that all of the research says they are never 100% reliable. This gentleman on the right is Dr. Richard Cook. He's not a software engineer. He's an anesthesiologist and a researcher who has spent decades working on safety in complex systems, and specifically patient safety in the world of healthcare. In his paper, How Complex Systems Fail, which I strongly encourage you all to read, it's very short and very readable, he explains what is common to complex systems in all fields from healthcare to software operations. And I'm going to share with you just a few of the insights from that paper, and you can think about how they apply to the stuff you work on. Complex systems contain changing mixtures of failure latent within them. That means that your system is never fully functioning. If you work on a system of sufficient complexity, you may believe that it's working correctly, but I guarantee you it's not. There are failures in it. Complex systems run in degraded mode. This sounds like the same statement, but it's actually saying something a little different. Your system works in degraded mode. Your system contains failures, sure, but it works with those failures present within it. And the last and most important thing for us about complex systems is that catastrophe is always just around the corner. The complexity of the systems that we work on means that major system failures are, in the long term, unavoidable. So what does that mean for us? It means that there are two things for us to think about. On the one hand, how to prevent incidents. But also, if things will eventually and inevitably go wrong, our ability to respond on the other. And these are not independent, they are interlinked and connected. Has anyone ever had the experience of introducing an automated system which worked most of the time and helped us and took load off human operators, but when it failed spectacularly and made it harder for operators to understand what had gone wrong? There are numerous examples like this, where we do something in order to prevent incidents that actually ends up making our lives much more difficult when it comes to responding to those incidents. I'm not saying you shouldn't try and prevent incidents. I think what I'm saying is you need to consider the fact that, yes, you can make technical changes and organizational changes to prevent incidents, but you also need to consider what impact those changes are going to have on your ability to respond. Perhaps this is now going to seem obvious, but I think there's a deeper realization here. The systems we work on are not just technical systems. In fact, I would argue we don't work on the system, we work in the system. Our systems, as Pat alluded to earlier, are systems that include humans. And how do humans respond when things go wrong, and how the humans work on a day-to-day basis, these are things that are as important as preventing things from going wrong in the first place. So what does this mean? Well, because our systems include humans, it means that language matters. The words we use affect how we think about what happened and can drastically change what and how much we learn. And this finding comes from research in safety-critical industries such as aviation, medicine, search and rescue, firefighting, and many more. And collectively, this field of research, which came into being and has developed since the early 80s, has become known as resilience engineering. We have a lot to learn about resilience engineering in our sector, and today I'm going to share with you 4 of the common traps identified by resilience engineering literature. We'll start by revisiting the story of the B-17s. Were you satisfied with the explanation I gave you earlier for these accidents? Pilot error. Good. This man wasn't either. This is Alphonse Chapanis, And he was a military psychologist who was asked by the US Air Force to look into this series of hundreds of accidents for which the conclusion was inevitably pilot error. And he noticed something. He noticed that this particular kind of landing gear retraction accident was unique to the B-17 and a small number of other models of aircraft. But there were thousands of C-47 Skytrain transport aircraft flying around Western Europe in the second half of World War II. Not one of them ever suffered a gear retraction accident. So he went and interviewed pilots. And on the basis of what he found interviewing pilots, he went and looked inside B-17 cockpits. And this is what he found. This is the central console of the B-17. On the left is the original diagram from the Boeing manual, and on the right is a modern reproduction. And I grant that it may be a little bit difficult to see, but if you look at the diagram on the left, switch number 5 is the switch to retract and raise the gear. Switch number 6 is the switch to extend and retract the wing flaps. Now, I'm not going to assume that you are all pilots. When you've just landed a heavy aircraft, your flaps are extended. When you park, you want them retracted. So one of the things that you'll be doing on your landing roll, on your way over to your parking stand, on your way over to your parking stand, is you'll be retracting the flaps. And what Chapanis realized was that pilots were simply reaching down to two switches which were in many ways identical and about 3 inches away from one another in the cockpit and just picking the wrong one. The switches have the same polarity, they feel the same, they're in the same part of the cockpit. The accident was simply too easy. It was too easy to confuse one for another. And so Chapanis tried something. He glued a little rubber wheel to the switch for the gear and a hard angular flap to the switch for the flaps. And hey presto, the accident stopped happening. Chapanis is now known as one of the founders of the field of ergonomics, which is the study of design factors in human performance and isn't all about your desk chair, although it is also about your desk chair. And he had a simple observation, which was that the design of the cockpit could affect the likelihood of human error. And this has gone on to inform the design of all modern aircraft. This is what the gear and flaps controls look like in an Airbus A320. The gear looks like landing gear, and the hard angular flap is in a different part of the cockpit. It has a different actuation mechanism. And this is called shape coding, and it is now mandated by federal law for all aircraft. I've told you this story to make the single most important point I have for you today. Attribution to human error is a lie. Humans do make mistakes, but human error is a symptom and not a cause. It's a symptom of issues with system design, organizational design, personal context, and so on. Human error is problematic in investigations because it causes us to lose sight of the fact that what the human did made sense to them at the time. They didn't intend to make a mistake. If we want to learn, we must not stop investigating when we find a human error. As I hope the story of the B-17s demonstrates, it is just beyond the human error where we start to learn interesting things about our system. So when you see or hear human error, that's okay. It's just a signal that you need to look deeper. The second trap is counterfactual reasoning. You might not know what counterfactual reasoning is, but I'm pretty sure you've heard it before. If you're in a post-incident review and you hear somebody talking about how something should have happened a certain way, or how something failed to do something, or somebody failed to do something, that's counterfactual reasoning. In all these cases, what's happening is that you're hearing somebody tell a story about a series of events that did not occur in order to explain a series of events that did. The engineer failed to check the validity of the configuration. This problem could have been picked up in the canary environment. The problem with counterfactual reasoning is this. If we focus in our investigations on things that did not happen, we're taking time and thought away from understanding how what happened. So avoid this trap by moving beyond the problem wasn't detected in the canary environment. Ask, how was it detected? Does the canary environment normally pick up issues like this? Trap number 3 is the use of normative language. Normative language is a little bit harder to detect sometimes, but often adverbs can give the game away. When somebody says something was done inadequately or carelessly, that's normative. What's normative mean? Normative language implies that there was an obviously correct course of action that operators should have taken and judges the actions of those operators with the benefit of hindsight. The problem with this is that the outcome is the one piece of information that we know was unavailable to the operator at the time they made their decision. I'll also just make a note that normative language can also be used in the opposite sense. People can praise operators for having acted appropriately in a certain situation. But again, this judgment is often made with the benefit of information the people in question did not have. We need to learn to judge decisions on the basis of their inputs and not their outputs. If we accept post hoc judgments made with information that was unavailable to the humans involved in the incident, we'll probably neglect to understand how their decisions made sense to them at the time. Because they did. If they hadn't, they wouldn't have made them. So ask about normal work. Ask about how does this usually happen? What signals were you looking at when you made that decision? And that brings me to our 4th trap. And our 4th trap is what my colleague Jessica likes to call the meddling kids trap, and it's our favorite. It's mechanistic reasoning. Mechanistic reasoning is built on the idea that we work on systems that are basically functioning correctly. A failure can only be explained by a component within the system which wasn't functioning correctly. If only those meddling kids hadn't gone and deployed that broken config, everything would have been just fine. The problem with this is it's not how our systems work. Let's have a quick moment of audience participation here. If you work on or lead a team working on a production service, please put your hand in the air and keep it there until I tell you to put it down. Go on, put it up. Great. Okay, now imagine the following scenario. Everything outside of your team continues just as before. Customers continue to use your service. Demand continues to grow. Dependencies continue to change. The internet keeps on interneting. But I'm going to tell you, you cannot touch your service. No deployments, no config changes, no control plane operations, nothing. Okay? Now, keep your hand in the air if and only if your service would still be running just fine a day later. A couple of hands go down. A week later. A few more hands go down. A month later. A year later. Oh, there's always one. I want to talk to you afterwards. But what you've all just demonstrated is that human adaptive capacity is the reason our systems are up and running in the first place. It's only through the human action and adaptability that the system works. So it's pretty silly to conclude that the system was basically working if it hadn't been for those meddling kids. The problem with mechanistic reasoning is it leads us down a path where we believe that finding the faulty component, and let's be honest, the component is usually constructed to be a human, is equivalent to finding the problem. Unfortunately, that same faulty human has been improvising and adapting and often doing exactly the same thing that you constructed as the fault for months or years to keep the system running. So perhaps there's more to look at. And that brings me to the end of the traps. I hope I've given you some examples of how the language you use and the questions you choose to ask can be critically important to determining how much you learn when investigating an incident. So these traps are things to try and avoid, things to be aware of. You might be asking, well, what should I do instead? And so now, in addition to the 4 don'ts, I have 4 do's, specific recommendations for you to take back to your team and practice from Monday. And the first is to run a facilitated post-incident review meeting. Far too many of us still rely on a single on-call engineer writing up a post-mortem document. And I can tell you, you're not going to learn that much that way. So, get people in a room, participants from the incident, with a facilitator to ask questions. And we'll talk more about the role of the facilitator in a minute. But review what happened in the lead up to and during and maybe even after the incident. And these meetings don't have to be, and I'd say they shouldn't be marathons. Most of the time, you shouldn't be going over an hour. 90 minutes, realistically, is the longest most of us can concentrate and participate effectively in such a meeting. If you're worried about making effective use of 90 minutes, prepare. Talk to the individuals who responded to the incident one-to-one. Interview them. They only need to be 10-minute interviews. Ask them about their experience and use what you find in those interviews to sketch out the timeline. Find interesting parts of the timeline, parts that surprised people, and structure your conversation around those. It's important that, if possible, your facilitator was not involved in response to the incident. Now, I do understand that for smaller companies this can be tricky, but I think you do need to try quite hard to have a neutral facilitator, because you will learn more if the person facilitating an incident review is not seen as having a personal agenda in telling the story of the incident. Depending on your organization, it's not usually a good idea to allow managers or people with organizational power into the room. I'm not saying that managers are bad, I am one, but they will change the timbre of the conversation, and they will change what is learned and how free people are about speaking about what they saw. I will have a suggestion a bit later for what to do if you have managers or executives who feel they need to be involved. And the last thing I say on this is, if you have a lot of incidents, as some of us do, you don't have to do this for everything all at once. Start small. Do one incident review a month. Do something that you think is going to be sustainable and build from there. And I'd also advise you, don't pick gigantic business-critical incidents. There are too many different things going on around those that you probably won't learn as much as you'd like to. Start with smaller or perhaps interesting incidents, things that really surprised people. Next helpful practice, ask better questions. As we've talked about, language matters. And often we ask why questions in incident review. But why questions will put people on the defensive, so I'd suggest that you prefer how questions. Don't ask, why did you do that? Instead, ask, what factored into your decision to make that change? Don't ask, why wasn't this caught in Canary? Bonus points, that's also counterfactual. Instead, ask, how effective is Canary at catching this sort of thing usually? And remember that each participant in the incident is likely to have had a slightly different view of the events that unfolded. Remember to ask questions that expose these multiple views and interpretations. They're interesting, and they embody learning. You'll often learn as much by asking about how work normally happens, too. Don't just ask about the specific incident in question. Ask about the broader context. Ask about normal work. Very often, in my experience, an action which is deemed to have caused an incident has been part of normal operations for months or years. Becoming an effective incident review facilitator, or frankly any kind of facilitator, is hard work. I make no claims to be particularly good at it. If you want to learn how to be a better facilitator, one of the best widely available resources is the Etsy Debriefing Facilitation Guide. There's a link on screen. There will be a link at the end. My third recommendation builds on key insights from the resilience engineering community. Many of us have a view of incidents as one-offs or as products of extreme conditions. But the reality is that in most complex systems, things go wrong for many of the same reasons that they go right. So don't just ask about how the outage happened. Ask also about how we recovered. What insights or skills were used to get the system back to working? What tools were useful? How did the people that helped bring the system back online come to be involved in the incident? Did that happen through the channels that you expected it to happen? Or did it happen because somebody happened to be walking past somebody else's desk and got pulled into the incident at the right time? Ask about these things. Was there a critical moment when someone shared a piece of information that helped unlock the puzzle of what was happening? How did they know to do that? Where did the information come from? And one of my all-time favorite questions to ask in incident reviews is, where did we get lucky? What worse outcomes did we narrowly avoid? So few people ask this, And I have had some of the most interesting discussions in incident reviews as a result of asking this question, and revealed things that engineers knew about the systems that they work on that nobody else knew. And this all comes back to what we said at the very beginning. We have as much to learn about how to improve our ability to respond to incidents as we do about how to prevent outages. And it's the job of a facilitator to find out how incident response actually works so we can get better at it. Your job is not to find ground truth. It is to expose the experiences and the knowledge of the people in the room. And so to my fourth recommendation, which is about when to discuss repair items or mitigation. You need to keep discussion of repair items out of your post-incident review. Otherwise, they will act as a distraction from the purpose of that meeting. I would suggest that you discuss repair items in a separate meeting a day or two after your post-incident review, and perhaps with a smaller group, perhaps with a group of people who are able to make decisions about prioritization for the future. This is going to help you in two ways. First, it'll help you in the post-incident review. It's far easier to avoid jumping to conclusions if you're not focused on how to fix things. You can keep the focus on understanding what actually happened, which is the job of the facilitator in the post-incident review. And second, allowing for a day or two of soak time will help you to identify what I would refer to as the most energy-efficient repair items, minimum energy for maximum impact. Your subconscious can help you, but you need to give it time. And I promised you this earlier. If management needs to feel involved in post-incident processes, this is when to invite them. In many ways, this is actually better than not having them involved at all, because in a planning meeting that comes after an incident review, they'll be able to learn about what is needed to address the issues raised by the incident without stifling the learning environment of the post-incident review itself. That brings me very nearly to the end. I'd like to conclude by reminding you of just three of the most important aspects of what I've shared with you today. The first is that we will always have incidents. Our systems are getting more and more complex, and no matter how much we would like to change that, it's not going to change. They will keep getting more complex, and 100% reliability is not achievable in a complex system. That means that our ability to respond effectively will always be important alongside ongoing and also valuable work on incident prevention. The second, human error is just a label, and it's not a very helpful one at that. It is a symptom and not a cause. We learn only when we seek to understand how what happened. And lastly, facilitated post-incident review is not the only tool that we have for learning about incidents, but it is one of the best and one of the easiest to apply in your organizations straight away. At its most effective, it can expose not only what went wrong, but what went right and how we can build on that. Thank you all so much for your attention. If I've successfully piqued your interest, you can find resources from this talk, as well as papers and videos which go deeper than I have today at this link. And I'd also like to call attention to a community attempting to learn more about learning from incidents, if that's not too meta, being run by my colleague Jessica, Nora Jones, John Allspore, and many other incredible people. Starting point for that would be LFI Software on the Twitters. Thank you very much.